Okay, Assalamualaikum warahmatullahi wabarakatuh. So this is the analysis of DC-DC converter, or specifically for the step-down converter, which is called buck converter. So this is the circuit. So as you can see, we have the input voltage. The switch should be a fully controlled device such as a transistor, the inductor, the capacitor, and also our load, and this is the diode. Okay, so actually the first analysis is actually to get the relationship between V out and also your VDC, where in theory the relationship between V out and VDC can be related as a D. So D is actually what we call duty cycle, which is actually the ratio between the time of the switch to turn on, the period of turn on over the period of the switching. Okay. So to be precise, it's actually what is actually D is actually, for example, this is the signal for switch. Okay, so for example, this is the period for our switching, which is T. So this is what we call T on. Okay, so the relay cycle is actually T on over T, and this is actually the time of T off. So T on over T is duty cycle. So if you have T off over T, this one we refer as a D prime, or you can write down as a 1 minus T. Okay, so firstly is so since this circuit record is actually involve switching, where sometimes the switch will turn on and sometimes the switch will turn off. So the characteristic of the circuit is quite different. So what we should do is actually to analyze the circuit for different switch condition. For example, the first one is actually we need to analyze the circuit when the switch is turned on. So what happened during the switch is turned on? So the switch is turned on right now. Okay, meaning that we use the inductor as our main function. So this is, as you can see, this node will be your VDC, and this node will be your V out. Okay, so since VDC is much more positive compared to this one, so meaning that your diode will be reverse bias, and we can turn on here. So meaning that the current will flow here to VDC, go straight to the inductor, resistor. Okay, so the KVL we can actually state as a negative VDC plus VL plus V out is equal to 0. And when we arrange this case, so we have VL is VDC minus V out. Noted that VL is actually L di dt. Okay, so we can substitute VL as this one. So L di over dt is equal to VDC minus V out. Then we can actually write again as a di over dt over VDC minus V out over L. Okay. Okay. And we know that the di over dt is actually the change. Okay, we can actually approximate any change of current over the change of time. Okay, and we know that change of time here is actually referring to the duration of T on, the change of T on. So we can actually substitute delta T as a T on. Okay, so finally we can actually rewritten our KVL as a change of delta L rewritten on over T on is equal to VDC minus V out over L, and finally we got delta L VDC minus V out of L multiplied with T on, where T on is actually D. Okay, T on is dt. So we substitute. Okay, so we have the first equation. We have actually complete the first analysis on during the switch on. Okay, so right now we continue with the analysis during turn off. Okay, during turn off, so meaning that the switch is open. Okay, what happens when the switch is open? When the switch is open, so the current of the supply is no longer flow. Okay, meaning that the current will be supplied by the inductor. So the inductor will actually discharge the energy. So the current will flow freewheeling inside this circuit. So since this is much more positive compared to this, so the diode will be actually turn on. Okay, will be actually forward bias, so it is can be considered as a short circuit. So the node here is 0 voltage because, as you can see, this is ground. Okay, and this one is V out. So we can actually write down the equation of VL as a VL is equal to because the current direction is like this, so 0 minus V out, or VL is actually negative V out. And as similar to the turn on analysis, where VL is actually, we can actually L DIL over, so DIL over DT, sorry, not DIL over DT, just state as a DI. Okay, DI of dt is equal to negative V out, and we know that this is actually negative V out over L, and actually delta T here is actually equal to T off. Okay, which is T off is actually 1 minus D T. Okay, 1 minus dt. So therefore delta IL is during the switch is off, can be write down as a negative V out over L multiplied with 1 minus dt. Okay, okay, so okay, I don't know why. Okay, so for steady state operation, the charge inside the inductor should be equal to 0, meaning that delta IL, the change of current of IL must equal to IL off, or in other words, delta IL on minus delta IL off should be equal to 0. So substitute this delta IL as a V DC minus V out over L dt minus so this is actually just okay, so V out over L 1 minus dt, so equal to 0. After we calculate it and so on, so we finally will conclude that we finally come out with the equation of relationship between V out and VDC, which is this equation. Okay, so for buck converter, so D is can be range from minimum is 0 to 1, meaning that V out can be equal to VDC. This is when D is equal to 1 maximum. Okay, and the minimum is actually when V out can be become 0. This is when D is at 0, which is the minimum value. So for buck converter, the maximum output is actually equal to the input, while the minimum output is equal to 0. So we will continue on the analysis on the inductor current.